I've got the task of speaking this morning about laboratory processing of FFPE fish. It doesn't get more exciting than that at 10 o'clock in the morning, does it? So it's a bit of a dry subject to try and make it as interesting as possible. So the overview of my talk in the next 10 or 15 minutes, I'm going to briefly touch on pre-analytical factors, then a bit about microtomy, then I'll talk through the fish processing pathway itself, touch on a bit about quality control in the laboratory, although we've got a talk by Sharon a bit more about that later, and then I'm going to briefly mention automation. So the fish processing overview. There are many different ways that people can perform fish in the laboratory, and each service will have its own special way and its own nuances of doing things. But the overarching main steps to fish processing are the deparaffinization, so the removal of the wax, a heat pre-treatment step to start to break down the tissue, then the enzymatic digestion and dehydration of the protein so we can access the DNA, obviously applying the probe, and then denaturation and hybridization, followed by a post-hybridization wash and counterstain. But before we do that, there's a number of different factors that we need to consider in the laboratory. And I guess the overarching take-home message here is poor tissue in, poor fish out. So for many laboratories, they won't have any control over these pre-analytical factors, whereas some laboratories will work in close correlation with your histology laboratory and may have some influence. It's worth kind of bearing in mind that certain factors will affect the quality of the fish. So in terms of removal of tissue from the patient, the cold ischemia time, so the length of time from removing the tissue from the patient to getting into fixative should be less than an hour. The size of the specimen impacts the quality of the fish processing in the laboratory. If the tissue is bone, it's good to use an EDTA-based decal, and that can be supplemented with ultrasound to improve that decalcification. The type of fixative buffer is incredibly important, so neutral buffered formalin is essential. We don't want our specimens to sit in fixative for too long because it starts to degrade the DNA. Less than 72 hours is key. Fixation temperature should be ambient temperature or down to 4 degrees. And ideally, for example, how do our blocks want to be? We know we fish on old blocks, but ideally less than 5 years old. And then the thickness of our sections. So somewhere between 2 and 4 microns is ideal. So if we get those things right in the histology lab, you stand a much better chance of getting decent fish out at the end. Just thinking about microtomy, sectioning and slide mounting. We can sometimes see in the histology lab that our sections are very thin and can tear easily and can become difficult to manage, disrupting the tissue. So the recommendation is to keep your blocks cold, put them on ice 20 minutes before sectioning. Don't forget to regularly change your blades so they're nice and sharp, and perhaps longer, more continuous rhythms are easier to manipulate. And then when mounting onto the slides, maintaining the water temperature of your water bath at about 40 degrees, but certainly not higher than 45 degrees, or you're going to risk melting your wax. Consider using implements to manipulate your sections, so tweezers or a scalpel. Use positively charged slides for fish sections so that your sections adhere nicely to your slide. Make the slides for an hour at 60 degrees. Adhere the tissue to the slide before you start your downstream fish process. So deparaffinization. Removing the wax, deparaffinization. It's recommended that you mark your slides before you start this process to actually remember where your tissue is. Really, really important to always use fresh solutions for your run. Not just using the same xylene again and again, because they'll be dirty, they won't take your wax away. If you're struggling to remove all the wax, you can add in additional xylene steps, particularly if you've got very big thick sections, for example. it's really important to say that if you don't get rid of all your wax, your fish quality is going to be poor. It's going to create autofluorescence. You're not going to be able to digest your tissue properly. So the next step, heat pre-treatment. There will be a number of different ways that laboratories can perform a heat pre-treatment step. For example, in our laboratory, we use a water bath, but I know that there are other methods. It's really important to ensure that your pre-treatment solution is kept to temperature. Ideally, we want to get our slides very, very hot, boiling 98 to 100 degrees C. If you are using water bath, for example, make sure that your water bath is constantly topped up. It seems like a simple thing, but as we process fish and have that high temperature, we're going to be losing a lot of water to evaporation. There are little techniques that you can use. You float ping pong balls in your water bath to minimise your evaporation, for example, but do keep your coupling jars full and your water bath to ensure that all your slides get up to temperature. Also, for every slide that you put in your coupling jar, you're probably going to drop the temperature by about half a degree. So don't process too many big ones, because you're going to reduce that temperature and you're not going to get up to that high 98, 100 degrees. It's going to work very well. And the amount of time for this pre-treatment step is variable depending on the tissue that you're trying to process. So we know that different tissues have different pre-treatment. Enzymatic digestion. So typically I would say that pepsin is the enzyme that is used for digesting tissue. Pepsin is a gut enzyme that breaks down proteins, but it also breaks down nucleic acids. So it's really important that we get our digestion step for the right amount of time, because we want to break down the proteins of our tissue, but we don't want to smash up our DNA. I would recommend that the slide of enzyme is kept at 37 degrees when that digestion step is taking place, but don't let your tissue dry out if you are doing it at 37 degrees. So you might need to top up with additional enzyme, and you could consider covering your tissue with a cover such as parafilm to prevent that evaporation. It's also worth knowing that you can stain your slides post digestion with DAPI to inspect them for that level of digestion, and DAPI easily washes. So if you're not sure if you've under or over digested your tissue, you can apply DAPI. And there's going to be some more talks later around what over and under digestion is going to look like. So thinking about different digestion times, again, there's no one right digestion time for all tissues. It will depend on the block, and you'll probably get very familiar with the blocks that you're getting from your internal organisation, but you might find that you get differences from external organisations because they may process their samples differently. But for example, tissues like the brain don't need that much digestion. They're very soft. They can be digested quite quickly, but lung, for example, we know takes longer, and certainly skin takes a whole lot of welly to be able to break it down. But as I've mentioned, we have to be mindful of excessive digestion, because we don't want to break down our nucleic acids and lose the structure of the nuclei and chromosomes. But probe application seems fairly straightforward. We get it out the freezer, we pop it on our slide. However, it's worth noting that we should let our probes warm up to room temperature before applying them. But if you're like us, where we're quite stingy with the amount of probe we put on our slide, that can mean that one tube can come in and out of the freezer many, many times. So we're really increasing those freeze-thaw cycles, which will affect the quality of the probe. So it might be worth aliquoting your probes into smaller working stocks and keeping your main stock in the freezer so that you reduce those freeze-thaw cycles. Fairly obvious, keep your probes out of the light because you don't want to break down the fluorophores. Doesn't mean you have to work in the dark, but maybe keep your probes under cover while they're defrosting. Ensure the probe is uniformly mixed before applying to the slide, particularly if they're dual colours. We've seen this where if you don't mix your probe properly, you suddenly find you don't get any red probe on your slide. Ensure your tissue is adequately covered by probe, and ensure that you use a good fitting cover slip, removing any air bubbles. And the best part for me, sealing with the rubber solution. It's my favourite part. And moving on to denaturation and hybridisation. it's critical to denature the tissue and probe at the correct temperature. And again, probably tissue specific, probe specific, and probably will have been verified and validated within your own laboratory. But I'd say it's really key that you keep your temperatures within 1 degree. We know that if you're struggling to get good hybridization and good denaturation, it's often worth increasing your temperature for tissue samples. So often we can take it up to at least 85 degrees. And then I think that this is something that shouldn't be underemphasized, is the hybridization chamber. It's really important that you have good humidity in your hybridization chamber. If your slides dry out overnight, or however long your hype is, that can really affect the quality of the fish. So make sure whatever system you're using, whether you're using a plastic box in an incubator, whether you're using a thermobrite, that your slides are in a humid condition. Post-hybridization wash and counter stain, and making sure our solutions are made up fresh daily. Ideally, your wash solutions should be neutral at pH 7. Always checking the temperatures for your solutions at all times to ensure they are within 1 degree. Remove your cover slips carefully, making sure you get rid of all your rubber solution. And then once washed, drain the slides, but don't let them dry out before applying your DAPI counter stain. I think with tissue fish, it's really important that you use a good DAPI with an anti-fade that is strong enough to enable you to see the tissue architecture, because that can help with your analysis. Make sure it covers that area, and once again, remove any air bubbles. And then in the literature, there are some recommendations that you leave your stain to develop in 10 to 10 minutes in the dark before analysing. Some people put their slides in the fridge or the freezer to help the probes develop. Quality control. I'm sure we're all very, very familiar in our diagnostic laboratories with the importance of quality control. So constant temperature monitoring, monitoring your solutions, monitoring the hot plate, monitoring your incubator, constantly ensuring we've got clear, good tracking that our temperatures are holding as they should be. Witness checks and control material. With unlike IHC, where a positive control on your slide, laboratories often don't use a positive control in every fish run. I understand that. We often don't have a positive control. It's expensive. So consider having some sort of witness check or electrical barcode scan to make sure that you're using the right probe on your slide. Down the microscope, probes are going to look red and green, and you're not going to be able to map them against a chromosome to ensure you've put the right one on. It could be very easily done. We all know how small probe tubes are, right? And it's hard to read the material, the words on the tube. So ensuring you have some way to ensure you've put the right probe on your tissue is vital. If you are involved in the histology process, block matching, make sure that the slides that were cut for your fish were matched to your block. I can see my excellent tech over there, and the number of times she said to me, Marianne, the slides, the shape of the tissue sections don't match. So they're all labelled the same patient, but the shapes of the tissue don't match. In the process, it's gone wrong. So ensuring that block matching takes place so you know you've got the right patient tissue. Recording lot numbers for each run. So that makes sure that we are keeping up with our quality management system. Where our processes and probes are validated and verified for use. And I know that Sharon's going to talk some more about that. And there is the potential for considering using control material if you have access and availability to it. And then my last slide is on automation. If you are a very big service and you are processing lots and lots of slides, you could give consideration to automation for your laboratory processing of fish samples. Just a selection of automated robots here that are available on the market. It enables increased throughput and reduced hands-on time in the laboratory. It enables standardized sample processes, so you know your slides are all going to be treated in the same way. This will give you a lean and efficient workflow. And this, as I've said, is very optimal for large services that are processing many samples. Particularly if you're integrated with histology, where these systems can also be used for IHC. However, automation is expensive. And these are large instruments that require space. So these can be considerations. You need to really make sure that you have the throughput to warrant introducing these automated systems. But in conclusion, poor tissue in, poor fish out. Pre-analytical factors should be optimised for downstream fish wherever possible. If you can have that dialogue with your histology laboratories, that's ideal. We recommend optimising your protocols for your own workflow so that they work for you in your hands, and that automation can be used for large fish services to increase efficiency and standardise. Thank you very much.
Thank you. So Fiona's just been checking. I'm just going to change the slides over and please.
Anybody? Thank you, Marianne. Anybody here got any questions?
Top tips? No.
To add in on the cold ischemia, it's not just the timing to formalin. If you're dealing with obviously excision specimens, that specimen needs to be incised because otherwise your tissue is still not getting fixed. So it's actually considering longer than just that 1 hour. If you're doing a breast sample or a colon, you need to make sure the sample is either opened or incised.
Right.
Which I can.
Excellent.
Got a question from the website. Are many labs using automation?
We use automation, fish, still using DACO on this.
Yeah.
We use that for chemistry as well. So we wanted to give the fish a try on there, and it actually works, I say, really, really nicely. We don't have any experience with any other automation within our lab, but yeah, the performance is just really good.
I can say for all the Scottish labs have got the VIP 2000.
Is that the Abbott
Yes.
platform? Yeah. Yeah, we're about to start a trial on this in conjunction with ours. I don't think it's common at the moment, though, is it? I think it's.
I don't think so, no. I think on the 6th, because our demonic fish is still integrated within our HMDA service. So, I mean, I'd say because we're using the DACO on this for a lot of our chemistry, it meant that we could get quite a good deal, I think, on the probes, because we use an awful lot, we're spending an awful lot with them, but I think, you know, it is quite expensive, isn't it? And if you, I guess if you need to buy in I don't think we would have done it if we were just buying it in new just for fish.
Yeah.
Because we'd already got the system in.
What about in terms of how much probe you have to use with these automated platforms?
Probe.
Yeah.
Yeah.
Quite scanty with our probe manually.
We used to just little tiny.
Yeah, that's what we. Yeah.
Carefully, and then just use a small. I think it's a 16 millimeter, like 5 microliters of probe, but it uses. I'm not sure exactly how much it uses, but it uses.
Should they be just DACO probes? They can use any.
No, it's just
any manufacturer, so you can use a generic probe or other probes, for example. We're not supposed
to. So we've.
I thought it could be off. It could be open to other manufacturers.
All right, I don't know, but
We've only used Agilent.
we've only used Agilent, so we've been transferring our probes either using their off-the-shelf design or designing our own probes based on our current design.
I've been very keen to design probes if we just buy them directly.
I suspect to see with the market coming, it's quite nice to have Agilent's problem as a problem rather than our problem to use bespoke probes.
With the VIP, you apply your probe separately, so you can still use it.
Oh, so it just does the automated process.
Yes, and then you do your fish afterwards, so you can use as much of whatever probe you want.
Yeah.
The other advantage as well is it's barcoded. So, you know, in terms of worry about putting the wrong probe on or this type of thing, because it won't let you basically won't allow it to put the wrong probes in the machine, it won't accept it. So I think that's quite, that's quite good as well. And obviously the time saving as well, because we do quite a lot of fish, so saved a lot of time.
So I'm just saying that they use a VP with 3 different protocols, different pre-treatment times, but still struggle with failure rates for some services, best being the most robust, seems to be the most robust. Do you have any tips for them?
Well, I mean, we have the same issue. There are some tissue types that we really struggle with and others that worked very well. And we have cracked that either. And I think it depends where it's come from as well. Because we're used to being able to process your own in-house samples, but if you get blocks from outside, like Jenky, we do struggle to get Jenky blocks to work in our hands, definitely. We have to give them a lot more pre-treatment and digestion than we would our own blocks. Now that could be due to the age or the fact that where it comes from is just a slightly different pre-treatment and pre-fixation that we're not used to.
Or the age of the blocks.
Or the age of the blocks. Yeah.
Okay, so in the interest of time, we'll move on to the next presentation. Just to reassure those people who are online, if we haven't managed to answer your question, we will have stored, the website will